All right, Calc, let's finish up 6.4, and we're just moving on. I hope you're all caught up with what you need. So notice that we have a continuous function f, and we've already talked about the antiderivative is the area under the curve, and that's really the main meat of this section. So if we're doing the area under the curve between 0 and 3, your bounds on this problem, what you might want to just refresh your memory on is because we have a semicircle, you might just want to think about, well, how would I find the area of a circle that has a radius of 2? So that's just a reminder there. Radius would be, the area is pi r squared, but because we only want this quarter of a circle so far, I would divide it by 4. So what's nice, I guess, is because r is 2, 2 squared is 4, divided by 4 would cancel. So this area would be pi. I hope that all makes sense. Let me know if it doesn't. But we also need this area, but these are perfect squares. This is a half of a square. It's a triangle. So it makes perfect sense to me to just say that's plus 2.5. So there will be times when you have the task of figuring out areas using area formulas, and you didn't have to do it this way as well. You could have done rectangle, with a base of 2 and a height of 1, so 2 times 1 is 2, and then a triangle with a base of 1 and a height of 1. Now as far as the next one goes, the value from 0 to 4, well, it makes perfect sense to me to say, okay, well that's the same as from 0 to 3 that we just found, f of x, dx, plus the integral from 3 to 4. And I think this gives you a nice visual as well. So like this answer we just found out earlier was pi plus 2.5. But then as I do from 3 to 4, well, it's below the x-axis, so it's got to be negative. And it's the same triangle as right here, so negative 0.5. So what's our best answer then? It would just be pi plus 2. Now, in all honesty, I would not do the problem this way, because I would look at this and say, oh, it's the same answer, except this area is going to cancel out with this area, so let's ignore that. In other words, this answer needs to be the same in this specific problem from 0 to 2, and then once I get that answer, I would stop. But that only works on this problem. That's not a fact for all problems. Let's change colors just to emphasize this next one, because we're doing from negative 3 to 3, but as you look at this problem, this is definitely symmetric with the y-axis, which means it's an even function, which means what we can do is just take the integral from 0 to 3 f of x dx and double it. So I'm looking at this answer and I'm just going to double that. Just make sure you distribute. So it's going to become 2 pi, and double 2.5, you get 5. That'd be the fastest way of doing that. I can pull up the answer key, see if there's any other way that he does it. No, not really. I mean, he just shows the work that leads to that answer. And he used the trapezoid formula here, it looks like. Ugh, I don't like that. Yeah, he even showed the work on all that. That's, ugh, I do not like that. But here's another trapezoid formula. I mean, if we're going to learn the rules, let's learn the rules, I guess that's my way of thinking. Anyway, notice he had a semicircle formula here instead of the shortcut that I told you about. So feel free to pause if you want to learn how to do the problems this way instead of the way I showed you. All right. Okay, now we're getting into a little bit more interesting stuff, because now what we're going to be given is an initial value. That's what this is. An initial value. And it's asking you, if we start at f of 0 equals 5, what's the value of f of 3? So the way I like to explain this is using the antiderivative. You don't have to do the problem my way. But what I'm going to do is examine the from 0, because that's the x value, to 3, this x value of f of x dx. Now, assuming that capital F is the antiderivative, which the directions say, then that's equal to, in the notes we talked about, f of 3 minus f of 0. And I might reference back to the notes when we talked about that. Right here. Right there. So we also figured out earlier from the very first question that the integral from 0 to 3 of f of x dx is equal to this pi plus 2.5. So I can set up an equation where this piece is equal to pi plus 2.5. And on this side, we don't know f of 3, but we do know f of 0 now. The initial value was 5. So I can solve this problem pretty easily by adding 5 to the left side. So this answer would be pi. We'll add 5 to that, and you'll get 7.5. And that is your answer. A quick note for things that we will do here in a few days. So let me write down the rule, because I think it's useful, and might as well do it right now. F of x dx. So we've seen this rule before. Capital F of b minus capital F of a. When we come across problems like this in the future, a lot of textbooks go ahead and do the preliminary work if this is your initial condition. Let me just jot that down. What they'll do is they'll go ahead and add that to the left side first. So f of a plus the integral from a to b of lowercase f of x dx, because they have to be antiderivatives of each other, is equal to capital F of b, which is the ending position, ending condition, I guess I should say. Let's see if his answer key is any different than how I wrote it. Oh, that's exactly how he wrote it. Well, I might as well just kind of talk about this right here, but I'll show you the work as well. Really the same work with the initial condition. So let me skip this step and kind of do it with the red work I just showed you on the page. But you can see how the work is almost the same. The only difference is we haven't done the integral from -2 to 2 yet. So you can pause the video, you can understand it this way, or you can see how I'm about to do it. So I'm going to use this red formula I just wrote down, which would say that f of -2 plus the integral from -2. And I should point out as well, I think it's super important, so let me highlight, this number and this number need to be the same. Otherwise, you need to do a little bit more algebra to get there. And then let me highlight that that number needs to be the same as the number that's going to be over here. Let's see if I can fit it in there perfectly. F of x dx is equal to capital F of 2. Yeah, that's pretty good. So now what I can do is say, okay, well, f of -2 is equal to 2. I better figure out this value is equal to f of 2, and then I'll get my final answer. Well, let's figure out what the integral is from -2 to 2. If I go back to the top, so we want from here to here. Well, if I do all the work the same way I did before, it's pi r squared divided by 2. R squared divided by 2. And the radius is still 2. And if I look at the rest of that I have 4 of those pieces. And r is 2, squared is 4, divided by 2 is 2. So we're going to have 2 pi plus 4. I hope that all made sense. If not, please bring your questions to class. When I combine like terms, I get 2 pi plus 2. And that's how I would do this problem. I think I just have a few more examples here. Notice in this problem, they give you the graph of the derivative. So pause the video, make sure you understand it. They even give you the directions that we have one line segment and a semicircle shown in the picture. So on what interval is f increasing? I like to write down my reason first. If f is increasing, that means that f prime is positive. Well, the only time that f prime was positive is on the interval from -3, x values, by the way, from -3 to -2. A lot of times they'll ask the phrase on what open intervals. I think they're getting better at writing those. And then here's your reasoning. Or you can write f prime is greater than 0. Okay, what about a point of inflection? Well, a point of inflection is the second derivative. Just a reminder. So you might write that down where the second derivative is 0, or you could say, I'm sort of hesitant to say it this way, but I'm going to say, or undefined. I would actually cross this off. I don't really like that reasoning, because what I'm thinking about is where f changes concavity. Again, I wouldn't write that down either. What I would write down is that f prime, well, if it's 0 or undefined, that means that the derivative has a relative extrema. Because as you look at this, we need to find where the first derivative changes from decreasing to increasing. So if the first derivative is decreasing, remember that means we're concave down. If the first derivative is increasing, we are concave up. And that also happens right here, increasing to decreasing. So this is, I'm going to cross this off because I'm not a big fan of those. I would rather see this reason at x equals 0 and x equals 2. Just curious what the answer key would say on that one. Oops, one more. Yeah, point of inflection, or the second derivative changes sign, so that means the first derivative has a relative max or min, 0 or 2. And maybe that reason's a little bit more clear for you guys. Let's go back. Remember the equation of a tangent line, you need the slope. So I would write down kind of this notation, f prime of 0. It's really what we care about. So f prime of 0 is -2. So now we can quickly come up with the tangent line. Y equals the slope. Now you can leave it as x minus 0, but minus 0 is not going to change the value of it, and then plus 3. And now f of -3 and f of 4. This is going to be interesting, all right? Because here's your initial condition. Now here's kind of an issue, is we're going backwards to figure out f of -3. But that's why I like that formula where I start with what I know. I know f of 0, and then plus the integral from 0 to -3 of f prime of x dx will give me f of -3. And in the same manner, I can do the same thing from f of 0 plus the integral from 0 to 4 of f prime of x dx will give me f of 4. And hopefully that makes sense from what I explained on the previous slide. So if I were doing that, then I would do a couple things. First of all, f of 0 is 3. I would actually want to change this to be minus the integral from -3 to 0, because I don't like to switch the signs around. And this follows directly, let me just highlight, this follows directly from our notes in this section. So then from there I can just look at that and say, oh, well, this area will negate this area. So the area I'm looking at is -1.5. So we're looking at 3 minus -1.5, which equals 4.5, is my answer for f of -3. I'm running low on time, but I don't want to make another video, so I'm going to jump to the answer key. He works it out slightly different, but gets the same answer there. And same thing here. So you may want to pause the video and try to work out f of 4 on your own, but then come back to this to see your answer. And now you should be ready for the homework. Please, please, please bring any questions you have to class. I'd love to answer them.